Okay, welcome back, YouTube. We had a little problem with the frozen activity from code.org. So let me redo this after the class. So you see what it is. Let's try this. We start with this.
I was 13 when I first got access to a computer.
My parents bought me a Macintosh in 1984 when I was 8 years old.
I was in 6th grade.
I learned to code in college.
Freshman year, first semester, intro to computer science.
I wrote a program to play tic-tac-toe.
I think it was pretty humble beginnings. I think the first program I wrote asked things like, what's your favorite color? Or how old are you?
I first learned how to make a green circle and a red square appear on the screen.
The first time I actually had something come up and say, hello world, and I made a computer do that. It was just astonishing.
Learning how to program didn't start off as wanting to learn all of computer science or trying to master this discipline or anything like that. It just started off because I wanted to do this one simple thing. I wanted to make something that was fun for myself and my sisters, and I wrote this little program and then basically just added a little bit to it. And then when I needed to learn something new, I looked it up, either in a book or on the internet, and then added a little bit to it.
It's really not unlike kind of playing an instrument or something, or playing a sport. It starts out being very intimidating, but you kind of get the hang of it over time.
Coding is something that can be learned, and I know it can be intimidating. A lot of things are intimidating, but what isn't?
A lot of the coding that people do is actually fairly simple. It's more about the process of breaking down problems than sort of coming up with complicated algorithms as people traditionally think about it.
You don't have to be a genius to know how to code. You need to be determined.
Addition, subtraction, that's about it.
You should probably know your multiplication tables.
You don't have to be a genius to code. Do you have to be a genius to read?
Even if you want to become a race car driver or play baseball or build a house, all of these things have been turned upside down by software.
What it is computers are everywhere. You want to work in agriculture? Do you want to work in entertainment? Do you want to work in manufacturing? It's just all over.
Here we are, 2013. We all depend on technology to communicate, to bank, information, and none of us know how to read and write code.
When I was in school, I was in this after-school group called the Whiz Kids, and when people found out, they laughed at me and, all these things. And I'm like, man, I don't care. I think it's cool, and, I'm learning a lot, and some of my friends have jobs.
Our policy is literally to hire as many talented engineers as we can find. The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
To get the very best people, we try to make the office as awesome as possible.
We have a fantastic chef.
Free food,
Breakfast, lunch, and dinner.
free laundry,
snacks, even places to play and video games and scooters. There's all these kind of interesting things around the office, places where people can play or relax, or go to think or play music or be creative.
Whether you're trying to make a lot of money or whether you just want to change the world, computer programming is an incredibly empowering skill to learn.
I think if someone had told me that software is really about humanity, that it's really about helping people by using computer technology, it would have changed my outlook a lot earlier.
To be able to actually come up with an idea and then see it in your hands and then be able to press a button and have it be in millions of people's hands, I think we're the first generation in the world that's really ever had that kind of experience.
Just to think that when you can start something in your college dorm room and you can have a set of people who haven't built a big company before come together and build something that a billion people use as part of their daily lives is just crazy to think about, right? It's humbling and it's amazing.
The programmers of tomorrow are the wizards of the future. You know, you're going to look like you have magic powers compared to everybody else.
It's amazing. I think it's the closest thing we have to a superpower.
Great coders are today's rock stars. That's it.
So puzzle number one. This is code.org/frozen. We're going to use a language called Blockly. It's sort of like Scratch, which is based on Java. You put blocks of code together to accomplish a task. So hi, I'm Elsa of Arundel. Help me create a single line. All right, so drag the move forward block and snap it to where you see run and hit run. But maybe we should see this little tutorial video first. All right, so this is the Frozen intro.
So, what grade are you in?
Second.
10th grade?
First grade.
I was in 8th grade when I learned to program.
I got my first computer when I was in 6th grade.
What gets me excited is being able to fix people's problems.
You can express yourself. You can build things from an idea.
Computer science is the basis for a lot of the things that college students and professionals will do for the next 20 or 30 years.
I like programming because I like helping people.
I get the opportunity to build something that's going to make people's life easier.
I think it's the closest thing we have to a superpower.
Getting started is the most important part.
I'm a beginner myself, and I want you to learn with me.
Hi, my name is Lindsay. I majored in theater in college, but I also majored in computer science. And now I model, act, and write my own apps. Let's use code to join Anna and Elsa as they explore the magic and beauty of ice. You will create snowflakes and patterns as you ice skate and make a winter wonderland that you can then share with your friends. In the next hour, you're going to learn the basics of how to code. Traditional programming is usually in text, but we'll use Blockly, which uses visual blocks that you can drag and drop to write programs. This is how even university students learn the basics. Under the hood, you're still creating code. The concepts that you'll be learning are what computer programmers use every day and are the foundation to computer science. A program is a set of instructions that tells the computer what to do. Let's build a code for a program that will help Elsa create a simple line. We will use this later to create more complex patterns. Your screen is split into 3 main parts. On the left is the ice surface where you'll run your program. The instructions for each level are written right below the surface. This middle area is the toolbox, and each of these blocks is an action that Elsa and Anna can do. The white space on the right is called the workspace, and this is where we'll build our program. To move around the ice surface, you'll use the move forward block. Here, the move forward block says, move forward by 100 pixels. When we press run, what happens? Elsa moves forward a certain amount on the screen. 100 pixels, in fact. Pixels are basically very tiny squares on your computer screen. The other block we have in this puzzle says turn right by 90 degrees. And when we use this turn right block, that makes Elsa turn a certain amount. You can play around with how far you want Elsa to turn. The angle is measured from the path ahead of Elsa. So this is a 90-degree turn, and this is a 120-degree turn. And remember, you can change the number of pixels or degrees by clicking the arrows next to them.
Alrighty, let's try that. So, our task here was to make her move 100 pixels forward to the right, along this line here. So let's do so. And try it. There you go. Alrighty. Now advance to the next Okay, let's see if I can move it forward myself. Congratulations, you've completed one puzzle. Show the code. Move forward 100. So it's really based on Java, JavaScript. So just a moment. Okay. So this is what it would look like in text. Okay, continue. Puzzle 2. It was loading very slowly today, that's why we had a problem in class. Let's see if we can get through here. Through to number 2. Come on, computer. Why is this taking all day? What is going on?
So,
And we did this already. Does it automatically go to number 2? Come on, go to number 2. It's supposed to automatically go. Ugh. It's loading. I'll give it a minute. Oh, there it goes. Alright, congratulations, you completed puzzle 1. You wrote one line of code, and we saw this already. That's what it looks like in Java or JavaScript. They're not showing you the graphic class, but that's not the viewer class, but the controller class. Yes. Alright, let's go to number 2. Yeah, on. See, we had a big problem in class. This took too long. Trying to do this during computer science, AP Computer Science. Oh boy, I have another one here. Alright, give it a moment. Oh, there we go. Now let's see if we can create 2 lines at a 90-degree angle apart. Alright, let's do that. Alright, so let's move forward. She wants to go forward, turn right, and then 90 degrees, and then move forward again, right? So here, and here, and here. And if you mess something up, you don't like something, you can go and do this, right? Anyway, let's do that. I don't want to forward enough. And boom. Okay, you just wrote 3 more lines of code for a total of 4. And move forward, turn right, 90 degrees, move forward 100 degrees. Is good. Alright, let's see. Load number 3. Go for it. Go on, you can do it. Alright, just let it load. It seems like we're halfway to making a square. Let's put 4 lines together to make a square. Alright, so that's simple. Attach more blocks here. Notice the gray blocks, I want you to leave those there and add to it. So move forward 100, turn 90. There you go. Then move forward 100, turn 90. Move forward 100, turn 90. Move forward. Alright, so we're going to let's do that again. So now we're going down here. Let's turn right 90 degrees again. Now we're facing this way. Let's move forward 100 pixels. All this was at 8 blocks total, right? So now we're here. Let's turn right and move forward. Forward, and did we do it in the number of blocks? Yes, that we wanted. You know, you can make this go really slow. reset it. Here's the code we wrote. Move forward 100 pixels, turn right 90 degrees, move forward 100 pixels, turn right 90 degrees, move forward 100 pixels, turn right 90 degrees, move forward 100 pixels, and done. Alright, but I didn't want to do that. I wanted to run it fast. Go to the next screen. It's loading something. We got 20 of these. I don't know if I'm going to be able to do all of this. It's loaded so slowly, but you get the idea. Okay, load number 4. Come on, you can do it. What's the video? Go.
Computers are really good at repeating actions. You can count to 10 or 20 or 100, but a computer can count to a billion or a trillion. It won't get bored and it will only take a few seconds. Whether it's counting or drawing or anything, computers can repeat things hundreds or even billions of times. In programming, we call this a loop. A loop is how you repeat your code over and over again. For the next puzzle, your goal is to help Anna create a square with the repeat block. Any blocks of code you put inside the repeat block will be repeated in sequence, as many times as you want. To draw a square, you could use the move forward and turn block 4 times. But the easier way is to tell the computer to move forward and turn by 90 degrees once, and then tell it to repeat this pair of actions 4 times. To do that, you need to put the move forward and turn blocks inside a repeat block. Remember, you can change the number in the repeat block to anything, and it will repeat what's inside the block that many times.
Alright, so let's make a square with the minimum number of blocks. Let's do it. Hi, I'm Anna, so I guess Ilsa's taking a break. Let's make a square with a repeat block, which uses fewer blocks. How many times? Well, let's find out. And should the repeat block, how many times should the repeat block loop to make the blocks inside? Make a square. Alright, so we're going to leave these, move 100 pixels and turn 90. So, let's see, move 100, turn 90, move 100, turn 90, move 100, turn 90, move 100, turn 90. I guess we got to do 4 blocks. So where we got 4 blocks, let's make it go fast. Go. Alright, load the next puzzle. The next video, come on, do it. It's not saying that we did it right or anything. It says, oh, you did it right, go on to the next thing. Here's show code, by the way. So here's a loop, a for loop, 4 bar count starts at 0, count is less than 4, count plus plus add 1 every time. Move forward 100 pixels, turn 90 degrees, then count is 1, do it again, then count is 2, do it again, then count is 3, do it again. Then count is 4, this just adds 1. 4 is too big, it stops the loop. Alright, so can we get to number 5? Come on, get to number 5. Looks like we didn't do 3, wasn't that the video? There you go. Congratulations, you completed puzzle 4. You just wrote 1 more line of code, and we saw it already, and continue. We're not going to be able to get our certificate if this isn't green. That's strange. We did it. Alright, puzzle 5. Let's create 3 squares, turning after each square. Make sure that you turn 120 degrees before each new square. So they want you to do a repeat a certain number of times. I guess once for each square, so that's probably 3. Then repeat 4 times and move forward 100 pixels and turn 90 degrees, so that makes 1 square at a time. But then let's turn right 120 degrees. Alright, let's make it fast. You ready? Go. Did it. Alright, let's wait for it to figure out that we did it right, and we did it with the right number of blocks. We have 6 out of 6 blocks. Perfect. Give it a sec. A minute. Give it an hour of code. I don't know. Don't mind period 9 starting. That was period 8 ending before. Are we doing this for period 6? Didn't work. Come on, load. Load the next thing. Let's go. Is it loaded or not? Come on. You can do it. Congratulations, you completed puzzle 5. Where is it? Waiting. Oh boy, what are we waiting for? Come on. See, that's why it took too long. We're trying to condense an hour code into a 40-minute class. This is ridiculous. I can't move too long. What is going on? Well, might as well look at the code. Let's see. So for var count 2 equals 0 to count 2 is less than 3, notice that it's not allowed to equal 3, right? Count 2 plus plus adds 1 to the count every time. Then inside that loop, we have another loop that operates 4 times to make each square, and then it turns right 120 degrees between each square. That's it. Alright, come on. I should just load the next thing. You say, oh, you completed number 5. Well, what if it just goes down to 6? Oh, there one. Ah, again, really? See, I should have waited. Go to the next one. Come on, it takes all day. This is really annoying. Maybe sneaking do this. Not messing that up. There's nothing loading. Come on, just do loading something. Let's go. Reload a bunch of this. Ah, there it is. You just wrote 2 more lines of code. Yeah, we only wrote this one, turning 120, this one is going 3 times. Okay, continue. Alright, give me 6, give me 6, give me 6. Is this 6? Oh, this is 6. Okay, can you create a snowflake using a beat want to make a square 10 times and turn 36 degrees in between each square? Alright, let's go 10 squares. Go 36 degrees in each one. Otherwise, it's doing 4 sides of the square over and over and over again, right? Alright, let's make this fast. There you go. Good. You completed number 6. Wow, look at that. It went straight to loading 7. It's great. You should go to, there you go. So it's 10 times here, 36 degrees. Alright, that's 6 is 7 loaded. There it is. use the repeat block to create a plus sign. Did you notice Elsa can move forward and backward? So you move forward, move backward, 100 pixels, or different number of pixels. You turn right, turn left, with different number of degrees. Okay, use this block and put it around the grid blocks. Okay. Move the repeat block here and place the grid blocks to the side. Alright, so let's move this down. Let's move this here. Let's move this here. So forward 100, back 100, right 90. Is that it? Okay, that's it. Alright, now it's going to take a while to load 8. Because this is a load. This is a load. 10 load. I don't want to skip the parallel. I can do that. You completed puzzle 7. You wrote one-line code. Yeah, just the repeat block. Show the code. So, for count equals 0 to 4, count equals plus, move forward, backward, turn 100. Alright, load 8. Come on, load 8. You can do it. This is 10. This is 7. This is 6. This is 7. Trying to get 8. 7. We did 8. Trying to get 8. 9. 10 is loaded. Load again. That's 8. That's 9. Load again. Not doing anything. 10 is good. Let's do something. There's 9. Okay, good. What about 8? It shouldn't work like this. Trigonometric. Sorry. That's 8. Okay, 8, 9, 10. I'm moving up to sea level. This is 12. This is 13. Coming up. Look like this is a little more. Oh, 8, there it is. Okay, now try repeating it 10 times. How many degrees do you need to turn between each line? Alright, so instead of doing forward, backward, turn 90, forward, backward, turn 90. We gotta go 10 times, so 10 to 360 is 36, right? So forward, back, this is all we gotta do is 36, right? What do we have to do? Oh, we have to repeat this 10 times, right? So get rid of this, put this here, this inside, make it fast. Go. Alright, that was 8, here's 9. Let's repeat it 90 times. How many times is 90 going to 360? Well, 4 times, right? Really? Okay. There's a random color. We're going to repeat this 90 times. We're going to put this whole thing in here. Right inside the 90. We're going to go 4 degrees. We're going to pick a random color every time it starts a new length, forward, backward length. These random colors are picked within a small palette that looks like, icy colors and stuff like that. So let's see how this looks. That's nice. Look at that. create a parallelogram. It's just like a square, but it has different angles, 60 and then 20-degree angles instead of 90-degree angles. Okay. So repeat block to create this shape. So we can only do this with 8 blocks. 5 blocks are taken already. They want you to repeat something, right? So let's go 100, then 60, then 100, then 100, then 20. See what that does. Good. Now we're going to do that twice. So use the repeat 2 times. Repeat 2 loops. And that's right. Forgetting something? We wrote 3 lines of code. Yay! So we added the loop there, and we changed the number of degrees, 60 degrees equals 20. Okay, so that's 10. Let's see, is 11 up? Yes. Is 12 up? Yes. Is 13 up? No. Is 14? Alright, let me give you these. So 12 is good. Alright, let's try to guess. Gonna make this one 13. Make this one 14. 15. Loaded. Well, we gotta get to 20. Alright, what do we want to do? Did you know every snowflake is a different shape? Let's create a new snowflake by using the repeat block. Repeat a parallelogram 4 times. Turn right 90 degrees between each parallelogram. Okay. So we want to do 4 of these. And it's repeating twice. This is what we just did to do 1 parallelogram. Then they want you to turn 90 degrees between each block. I think that's it. Let's try it. There you go. You just wrote 2 lines of code. And what were they? I think we changed this into 90 degrees. We changed this to 4 iterations. Good. All right. Now I have 12. So here's 12. Here's 13. Here's 14. Here's 15. Let's go back to it. All right. Now let's create a new snowflake by using the repeat block. Repeat a parallelogram 10 times. Turn right 36 degrees between. So let's do this 10 times. Let's put this in here. This repeat do loop goes twice with each parallelogram. And then we have to turn 36 degrees. Just 10 of them. 60 degrees. 6. Circle is a special shape. Can you figure out what number to replace the question marks with? Okay, repeat this a whole ton of times. So 1 pixel and 1 degree. How about 360 times? Is it going 1 degree at a time? Let's see. There you go. All you did was that 1 line where you put the 360. Right? Okay. All right, then. That was 13. Yeah, we don't need 12. This is 13. We did that. 5. Is this 14? Yes. Is this 15? Yes. Let's preload some more. I need 16. the new circle, create a circle block to create 10 overlapping circles. Don't forget the jump between. Okay, so create a circle there is a function that encapsulates everything we just did to make a circle. That's what this video is.
One of the most important concepts in computer science is how to define new commands, how to add your own words to a computer language. Most computer languages have only about 100 words or commands, and really the art.
Wait, that's going too slow. Let's try this one.
One of the most important concepts in computer science is how to define new commands, how to add your own words to a computer language. Most computer languages have only about 100 words or commands, and really the art and magic is in defining your own new words out of these building blocks. We do this all the time in sports. For example, in basketball, you start by learning how to dribble, how to do a layup, how to rebound. Once you've learned these really basic moves, you learn new moves and put together these building blocks, like a pick and roll or a give and go. And you can then go from there to do more complex plays. And once you learn that play and give it a name, everybody on the team knows how to do it. Similarly, once you've taught a computer how to do an action once using these sequence of commands, you can make up your own name for that action, so it's easy to repeat it later. When you define your own command and give it a name, that's called a function.
When programming with blocks, you would use functions if there are a set of actions you're going to want to use lots of times. For example, you've written code to create a square. You can define this as a function called createSquare. And now you have a new block that you can use multiple times to create multiple squares. A lot of simple shapes can be used to create more complex patterns. In the next puzzle, the code you recently wrote to make a circle is available to you as a new function that can make circles of different sizes. Can you use it to help Elsa create intricate and beautiful patterns in the snow?
All right, so let's try. Hang on. Just a moment. Be right with you. Okay, here we go. Alright, so let's go back over here. Alright, so use the new create circle block to create 10 overlapping circles. Don't forget to jump forward between the circles. Alright, so create a circle, jump forward. Gee, I don't know. How far do you want to jump forward? How about 25 feet? And then we're going to repeat that 10 times, right? So let's put a repeat block here. Create the circle and jump. Because otherwise it's going to write over the same circle all the time. So do that, then jump, then do it again, jump, and see how that goes. Nice. Okay, so we have 15 over here. Sort of. That's 14. We did 14. Well, there you go. Here's the code that we wrote. All we did was add the 10, the repeat block. It went 10 times and jump forward 25. Let's see if this loads 15 for us. Not. I don't need 14 again. Here's 15 right here. Load here. All right, let's do 15 right here. Now let's create 20 overlapping circles, turning 18 degrees between each one. All right. Don't forget to turn after each one. Move forward, jump forward, repeat, how many? Alright, 20 circles. Create a circle. Jump forward, well 25 seemed to be enough last time. Oh, it's 50, maybe it's 50. And don't forget to jump 50 and turn 18 degrees. Alright, see, that's good. So you small circle size 5 and then a larger one size 10. Okay, so let's do one size 5. I guess that's a radius, pixels. And then another one with size 10. And try that. Perfect. That was 16. Show the code. There you go. So move forward. Yeah. Alright, just show the code again. Alright, so create circle. Okay, bar from 0 to 36. Move forward 5, turn right 10. Otherwise, move forward 10, turn right 10. Interesting. Alright, so the 5 actually affects the circumference. Okay, continue. File R17. I do. Intricate snow patterns can be created with very simple shapes. Can you make a pattern by repeating 5 circles of size 5 and 5 circles of size 10? Alright, so here's 5. Here's 10. And they want you to do 5 of these, so put this whole mess and repeat the block 5 times. And then 5 into 360 is 72, right? Let's see how that works. See code? Alright, so here's your circle, here's your circle, here's your turn right 72. And continue. Alright. Okay, so let's see, that was 17, so this is 18. Try using the create a snowflake branch. It's a branch. Block to create the snowflake branch block to create 3 branches which starts to look like a snowflake. So she's going to go do this thing, then we got to turn about 45 degrees. And turn, okay, so we're going to do this. Turn right 45 degrees. But then we're going to put it in a repeat block and go 3 times. Code. Alright, so all this craziness is to draw the branch. We're going to do that 3 times, turn 45 degrees, and then the branch is all this other stuff. Okay, so this 19 over here. Now let's repeat that 8 times to make a beautiful snowflake. So, then we turn right 45, and we're going to repeat the whole thing 8 times instead of 3. Speed it up. And let's see the code. There you go. 45, there's 8 times, there's the branch. Doing that 8 times. And we have 20. 20 number one. Let's get rid of this, 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 this. This hopefully is loading 20. This is loading. Let's try this again. I think 20 is just free form. Draw whatever you want. And then you get a certificate. And I don't know if you can see it on here. Come on, you can do it. Wait, this is promising. There. You've officially become a master artist. Create a window wonderland. Alright, well, we spent a lot of time on this, so I don't go crazy, but how about let's repeat 3 times. Create a square. No. Create a square. Where's square? There's no square there. And let's go, let's turn to the left 120 degrees. Let's see that. Alright, I think we're done. Okay, let's put while we're behind. That's all 20 slides, so we should get a certificate. Yay! Alright, so I'm gonna put in my name. I'm gonna share on Twitter. EdTech, Math Chat, SciChat, Comp Sci, STEM, and STEAM Chat, Science, Technology, Engineering, Arts, and Math, and HPC. High Performance Computing, we're in fractals there too, see? And boom. And I don't know how to print everything. I shared the Twitter that goes to Facebook also, there it is. I don't know if I can print this directly. This. It's just that, really. Blow this up. Ah, there it is. And that. That's my preview. I gotta do landscapes. I can't prove that. Okay, good. There you are. Alright, YouTube, that's enough. Bye bye. Hope you enjoyed. You got something out of it. Have a nice hour of code yourself.